Today, we're going to break down a concept that is absolutely fundamental to engineering. I'm talking about everything from a massive chemical plant all the way down to your coffee maker. It's called mass balance. And trust me, while it might sound a little intimidating, it's really just a super powerful way of doing bookkeeping, but for, stuff.
At its very core, mass balance all comes down to this one simple idea. But this isn't just some clever saying. It's really just another way of stating a fundamental law of physics, the conservation of mass. You can't just create matter out of thin air, and you can't make it vanish into nothing. So what does that mean? It means you have to account for it, every last bit.
So to really wield this principle like an engineer, we need to speak the language. And luckily, there are only 5 key terms we need to learn to describe exactly what's happening to mass inside any given system.
First up, you've got input. This one's pretty simple, right? It's just any mass that crosses the boundary and comes into our system. The best way to picture this is filling up a bathtub. The water flowing in from the tap, that's your input. And of course, on the other side of the coin, we have output. This is any mass that leaves the system. Sticking with our bathtub, this is the water that's going down the drain. See? Input is what you put in, output is what goes out. Easy peasy. Okay, now things get a little more interesting. Let's talk about generation. This is when a substance is actually created right there inside your system, usually because of a chemical reaction. Think about a bath bomb. You don't pour the fizz into the tub, do you? No. The reaction between the ingredients generates all that carbon dioxide gas right there in the water. And the flip side of generation is consumption. This is when a substance gets used up or disappears. In that bath bomb example, the solid stuff that made up the bomb, the citric acid and baking soda, they're being consumed as they react to create all that fizz.
So you've got stuff coming in, stuff going out, stuff being created, and stuff being used up. What's the bottom line? Well, that's accumulation. It's the net result of everything else. Is the total amount of stuff in your system going up or down? Back to our bathtub. If more water is coming in from the tap than is leaving through the drain, the water level rises. That's a positive accumulation. But if the drain is faster, the level drops. That's negative accumulation.
All right, now that we have our 5 key terms down, we can put all the pieces together into one beautiful, powerful mass equation that pretty much governs every mass balance problem you'll ever see. And here it is. This is the complete rulebook for matter. It just says that the change over time, that's the accumulation, is simply what you add, your inputs, minus what you take away, your outputs, plus what you create from scratch, the generation, minus what you use up, the consumption. You see? It accounts for absolutely everything. And of course, this is how engineers usually write it down, a nice, clean, short version of the exact same rule. Accumulation equals input minus output plus generation minus consumption. This little equation is the foundation for everything else. Now that full equation is fantastic, it's totally complete, but in a ton of real-world situations, we can use a really common, really helpful assumption that makes our lives way easier. And this brings us to the idea of steady state. So what is steady state? Well, a system is at steady state if it's basically on cruise control. It's stable, it's unchanging. Think of a river just flowing along. The water level isn't rising or falling, it's just moving through. The conditions right now are the same as they were an hour ago, and they'll be the same an hour from now. So think about it. If nothing inside the system is changing over time, what does that mean for our accumulation term? Right, it has to be 0. Nothing's building up and nothing's being drained away. This one little fact that accumulation equals 0 is an absolutely massive shortcut for us. And this is where the magic really happens. On the left, you see our big general equation. But the moment we assume steady state, poof, that accumulation term just becomes 0. And then we can just rearrange the equation into that much friendlier form on the right. What comes in plus what's created has to equal what goes out plus what's consumed. So much simpler.
But wait, we can make it even simpler. What if there are no chemical reactions happening at all? Well, then generation and consumption are also 0. And that leaves us with the most intuitive, common sense balance of all. What goes in must come out.
Okay, so that's all the theory. Now let's actually see how these equations work in the real world. We'll apply them to 3 classic simple systems. Think of this table as your little cheat sheet. If you're looking at a simple mixer or a splitter that just divides the stream, there's no reaction happening, right? So for those at steady state, the balance is just in equals out. Done. But if you're working with a reactor where chemicals are actually changing, you have to use the version that includes generation and consumption to get the right answer. It's all about picking the right tool for the job. All right, that was a really quick tour of a huge topic. So before we wrap up, let's just pause and boil this all down to the absolute key takeaways you should remember from this. First, remember that all of this is built on the law of conservation of mass. You can't create or destroy matter. Second, that master equation is your complete toolkit. It always works. Third, that steady state assumption, where accumulation is zero, is your most powerful shortcut. And finally, for so many simple systems, this all just boils down to that beautiful idea that what goes in must come out. You know, at the end of the day, this isn't some abstract concept just for engineers. It's really a framework for understanding how all kinds of systems work, from your bank account to the population of a city. So I'll leave you with a question to chew on. What system in your daily life could you apply a mass balance to? Thanks for watching.